Hello all, welcome to our project Bank Customer Churn Prediction. The main aim of this project is to predict whether a person will leave the bank services, that is, he will she will churn or not using the machine learning techniques and the auto machine learning techniques. So first let us understand what is churn. Basically in general, churn is expressed the degree of customer inactivity or disengagement observed over a given time. Basically, the simple meaning of churn is that if you do not perform any activity, if you have a bank account and you are not withdrawing money, or you are not using the services of a bank, you are likely to withdraw your account from that bank. That is, you are not using that bank usually. That is the main thing. That is known as churn. If you leave the bank, that means you have churned. This manifests within the data in various forms such as the recency of account actions or change in the account balance. So this is a very interesting problem for the bank if they could know that which customer will churn or not. We'll build a machine learning model which will predict us the same. So, what are the aim of our project? We aim to accomplish the following. Identify and visualize which factors contribute to customer churn. We'll see what are the different factors in which in the data set given. We have a data set in which there are various factors which we will observe and tell that which factors are the most necessary, which tells us that which customer will churn or not. And then we'll build a product prediction model that will perform the following. It will classify a customer if whether he or she is going to churn or not, or preferably, and based on model performance we'll choose a model that will attach a probability to the churn to make it easier for customer service to target how hanging fruits in their efforts to prevent churn. That means it will help the bank to prevent their customers from churning. They'll provide those services. They'll provide some additional services which will help them to prevent their customers from leaving the bank. This is a very fruitful statement and a very fruitful problem is if proved successful for the bank. Now, how we will do it? In this project we'll use neural networks in the machine learning system. Neural networks, basically the artificial neural networks, are just simply called neural networks, are computing systems inspired by the biological neural networks that constitute animal brains. Basically, neural networks are the same artificial structure with and perform the same thing which works in a human brain. These neural networks are unsupervised machine learning, the same as a brain. As a brain learns the things from observing itself, the neural network works the same. There is various neural network models. In this project, we'll be using the sequential neural network. What sequential model do? It allows us to build deep neural networks by stacking layers one on top of another. What happens is we have one input layer in which we give our data, and then there are certain hidden layers, right? There are certain hidden layers in which various information will be stored, and with the help of those information, the model will learn what are the different actions it have to take and what are the different predictions outcomes, and many different complex algorithms and actions will take place into those hidden layers. And then finally we have the output layer in which the model will give us the output. There is a very huge theory on the base of neural networks. This is just a basic understanding of that how these neural networks perform in layers. We'll be seeing how we can implement this in a machine learning model in a project, and then we'll shift to auto machine learning techniques, which are main aim. So, what is auto machine learning? Auto machine learning enables developers with limited machine learning expertise to train high quality models specific to their business needs. So what happens is, if I am a person and I don't have much machine learning knowledge, right? So I don't want to build all that model. I don't want to validate all those models. What I can do is I can use auto machine learning. It will do all the work for me, right? Like in our case, we are using H2O AutoML. The best thing about H2O AutoML is it can perform the data pre-processing techniques. Their pre-processing techniques include all the one-hot encoding part, removing outliers, handling NaN values, all everything. It is done by a H2O AutoML part, and all obviously the model building and hyper tuning is done, and gives us the best model. H2O AutoML is a very popular auto machine learning library, and we'll be using and seeing how we can implement this in our machine learning model. There's a brief definition. H2O is a fully open source distributed in-memory machine learning platform with linear scalability. Okay, H2O supports the most widely used statistical and machine learning algorithms, including gradient boosting machines, generalized linear models, deep learning, and many more. As you can see, these are different machine learning models you should have known. So H2O uses all these models and gives us the best model according to a problem statement. We'll be seeing how we can implement all of these in the upcoming project, in the upcoming videos. Now this will be the timeline of our project. First we'll do some data analysis practices. We'll find out what are the different relations and which factor are related to a churn or not. Then we'll do some feature engineering in which we'll pre-process the data, we'll build new features, we'll according to our need, and we'll see how they are correlated and many more. Then after the pre-processing of data, we'll feed that data into a model. We'll use different ANN models as I discussed earlier. Then we'll build our model using the auto machine learning technique, and we'll see which model suits our data best and is given by the auto machine learning, that is H2O AutoML library. So let's begin. Hello, welcome to our project Bank Customer Churn Prediction using H2O AutoML. I have already given you a brief introduction about the project, like what is the main context of the project, what is churn basically, and what is our main goal in this project. So now let's proceed with the coding environment and how we'll build the machine learning model using ANN and of course H2O AutoML. Now, this is the context which I've already described. The churn is expressed as a degree of customer activity or disengagement. And these are the aim which will be followed, like the will accomplish the following study, identify and visualize which factors contribute to customer churn, basically the data analysis part. Then we'll finally build a model after the pre-processing techniques. This is the timeline of the project. The data analysis part, feature engineering, model building using ANN, model building and prediction using H2O AutoML. So now let's first import all the libraries, essential libraries, which are the pandas and matplotlib numpy. These are the libraries which will help us in data analysis and pre-processing part. Okay, this line matplotlib in line is basically a magic line. What this do, that it will make sure that the graph which you plot appear in this same notebook only. This is a basic coding knowledge. Now as we are working in a Google Colab environment, there is a certain way to import our data sets. The very first thing you have to do, if you want to import a file in your Google Colab environment, you have to import that file in your Google Drive first. Okay, import that file in your Google Drive. Then what you'll do, you'll mount your drive. What you can do, you can click this button. This is mount drive. When you'll click it, it will give you this command. Okay, you have to execute it. You have to execute it, and I have already mounted the drive, right? Drive already mounted at content on drive. So what it will do, when you'll click it, it will give you a link. You have to go to that link. It will open a Google accounts window. You have to select your account, give the permission, then it will give you a link again. You have to copy it and you have to paste the link here. Then there will be a drop down box. You have to paste the link and press enter. Your drive will be mounted. Then what will happen? Your drive will be shown here like this. See this drive. Then this is my drive. These are all the contents which I have. Now I have already uploaded my CSV file in the Google Drive which I mounted. So I'll just copy the path, the churnmodeling.csv. This will be provided to you, and I'll paste the path here. Okay. So now I'll just simply execute it. I'll read it using pandas. Then I'll see the df. So this is my data set. So what have now, there is one thing, that there are certain columns like, right, now row number, customer ID or surname. These columns are of no importance. Row number is of no, that's the same as the index. I have no use of customer ID. I have no use of surname. So what I'll do, I'll drop these columns and I'll use the in place true. What this command will do, this will replace this dropped into the original df column. I don't have to define it after and after. Now let us see once again. So this is our final data set, and this is our data type. Some are integer, some are object, some are float. So this is our final data set. Okay, we'll be doing some data analysis part on seeing what are the different trends in this data, and then we'll be doing some feature engineering part, data pre-processing part like one hot encoding, handling outliers, handling NaN values, etc. and all of that sort. Then we'll finally build a model using the NN, and then finally using the auto machine learning, that is the H2O auto ML. This all will be performed in the next upcoming sections. So you see you all in the next data analysis video. Hello all, welcome to our next section of the project, that is the data analysis part. Now in this part of the project, we'll analyze our data, we'll see how our data is distributed and how the different models, different attributes are responsible for the product, for the customer to get churn. Basically our first aim was what? To identify and visualize what factors contribute to customer churn. So this will be done using the data analysis part. So first let's have a look at our data. So this is our data, right? After excluding the customer ID, row number and surname. So now let us understand these attributes. What are these columns are? First is the credit score. So credit score is basically a score which you get when you use your it is given by the bank. Okay, it is given by the bank on the time of how frequent you use your credit card, how you use it, and how are you using the bank services. Based on that you get your credit score. Now geography, now this is basically where you belong, okay, where the person belongs. If the person is from France, or if it's from Spain or another, okay. Now we'll see what are the different unique categories in each of these are by the df non-unique command. Then the gender, basically it will have two only, the male and the female. The age of the person. Tenure is basically the time period. The time period, if like it is in years, like the two, that means the customer is from 2 years, okay. That person is that bank customer from 2 years. If it's 8, means it's a very long customer, okay, a very valuable and very long old customer of the bank. 8 years. This is the balance, like the bank balance of the customer. This is the number of products, like the products or the services which maybe the bank has credit card, basically one if the customer has the credit card, zero for another case. Is active member, which means that if the person actively uses the bank, if he withdraws the money actively, and if he does all the transactions and uses the services actively, then it's a 1, then else it's a 0. Okay. Then estimated salary, the salary of the person, okay. The salary is if it's a savings account, so it must be connected to the salary account. Those the salary must be coming in into that account of that person. So this is the given salary, that how we can see that how salary is contributing to the exit of the customer or not. Now this finally is the exited part. One is like that person is exited, like it has churned, and 0 means that it is a valuable customer and a faithful customer, it has remained the customer of the bank. So now let's see what are the different values for each of these attributes. As you can see, credit score has around 460 different values, okay. There are 460 different credit score. Geography means there are 3 different regions. We'll see what are these. Gender, the male and female, obviously. Age is 70 different values, right? There are 70 different age people. Tenure are 11. This means there are 11 values of tenure. Balance, number of products, there are 4. Has credit card, 1 and 2 obviously. Is active member, same, 1 and 2. Estimated salary, as every member will have a different estimated salary. No one can have the same estimated salary. This is the 9999 column of the total columns. We have total rows we have. Exited also 2, that is the 1 and 0. So now what we'll do, we'll start with our data analysis part. First what we'll do is we'll draw a pie chart. Let me write here. We will plot a pie chart. We'll plot a pie chart in which we'll see that how many customers have churned and how many customers have not churned in percentage. So when I'll just execute it. See how beautiful this chart is. This is showing me that 20.4% customers have exited, that is they have churned, and 79.6% have retained. How did I do this? That is the very simple code I wrote, in which I use the labels, define the labels, which is the first is the exited, that is the churn, that is the retained. Then I gave my data in the first data sizes. In the first data which I gave is df dot exited give me that count in which the exited value is 1, that is the person has churned, that is the person is exited, and for another give me the value in which the value is 0. I'll explode, which means the same thing you're just seeing. Explode this rest by 0.01. Then I'll plot my figure, which is the plt.subplot. This is the size which I have used. You can change it. Then this I am pie. This is pie, which means I'm plotting a pie chart. Okay, sizes. I've already given the two sizes. If I'd be giving different sizes, then this will be the different number of partitions it will give. I have given two sizes. That means there will be two partitions. Explode is the one, then labels, then uh, this is the percent, like how it will get distributed. Shadow is the true. This is basically a start angle. These are basically the visualization effects which are used. The axis is equal, and the title, this is the title which I have given. Then this is finally I am showing my come out. This size is 20. Okay, this is the size of the title, how I want it. Okay, so this is a very simple command how you can write a pie chart. Now, in the next, and now we see that around 20% have churned and 80% have retained. So the churn percent is quite less, or basically we can say a little number. Now what we'll do, we'll try to see the different categorical variables and their relation status and their status with the churn, which means that they how and which category have exited in that particular category. Okay, in that particular place. So now what I'll be doing, that I'll be using a count plot. Okay, I'll be using a count plot in for the different categorical variables, in which I'll be making the hue as exited. Hue is a parameter which helps us to distinguish. Okay, if I made the hue exited, that means it will distinguish that data on the basis of my exited column, that is the 0 and 1. As you can see, first is my count plot for geography. Okay, it is telling me that there are three geographies: France, Spain and Germany. It is telling me what is the count of those people and which number of categories belongs to the 0 group, that is the retained group, and the 1 group. As you can see in a data set, the majority of the population is from France. Okay, the count is very high. Then is followed by Spain and Germany, which are almost equal. And and the churn condition, okay, the churn is also maximum in France only, okay, because also of the population. But in comparison in relative to that, the Germany has the maximum churn, because it has the customers are only around 1600. Okay, and the churn is around 700 to 800. And in the same in the case of France, the customer is around 4000, and the customer churn is around 600 or 700. Okay, so relatively the France is the lowest the people are churning, but in numbers we can say that France is the most. Now in the females, in the next is the our gender section. As you can see in the gender section, our male candidates are more. Okay, male candidates and more, and female, and you can see that the female count, though the female count is less, but the churn female count is more than the male. Sorry, more than the male. Okay, around 1100 customers have churned, which means that female customers are the more towards leaving the bank. Next is our has credit card. Now, as we can see, surprisingly, the person who are having credit card are more into the churning part. Okay, so and the majority of the population are having the credit card, but in that also the churn population is more, around 1200. Around 1200, the churn population is more. And similarly, active member does not have any much effect. Both are equal, both are in equal in proportion also. Okay, but also in that the one is not, obviously the one which is not an active member will churn. It is basic knowledge, or it is obvious. So this was a simple plot on my categorical variables. Now what I do, I use a simple count plot command. I give my x variable hue as exited, data is my df, which means it read the data, and x array, what it will do, it gave the position to my graph. The 0 0 is this part, 0 1 is this, 1 0 is this, and 1 1 is this. Now moving on to my continuous variables, to see how my continuous variables are affected, by how these affect my churn rate, I'll use a box plot. Box plot is an amazing way to check how our data is distributed and how is it related. The same thing I did, I used a box plot. I gave my y as my data, x is my edited column, hue is my to my exited 0 and 1 data df and array to the same position to assign the position 0 1 0 0 1 0. That's all. Now moving on to analyzing part. Now when we'll come to the credit score, we'll see that there's not much difference. Okay, there's not much difference. Thus, it is approximately the same. The people who have churned and people who have not churned, we can't really tell the difference from the credit score. Okay, so this is not predictable, not very much very valuable. Now when coming to the age, okay, now here's some difference. We can see that the person who are churning, okay, the person who are churning are basically of older age, like above 40, above 40. These person are likely to churn. The younger population between 30 to 40 are less likely to leave the bank. Now the third one is the tenure. Now, surprisingly, what happens is the person which are having the which have spent the most of the time, which are the oldest member and which are the newest member, are the ones which are most to churn. And the minimum, like average customer from 4 to 6 year are more to retain in the bank, or they are not leaving the bank. But the customer which are leaving from which are a customer from a long time, or they are have joined a recent time, they are more to leave the bank or to churn. Now from giving the balance part, there's not much difference to tell, but obviously the person who are having less balance are not likely to churn. Moreover, the actually the balance is quite same. As you can see from the graph, it is quite same. Okay, the top mark is same, only the bottom mark differs a little. We can't say much about balance here. The same goes for number of products. It is absolutely the same. You can't tell any difference. And the same for exited is obviously the same. Oh, estimated salary, is it also the same? Okay, you can't tell much difference. So the basic main defining factors were in the continuous variables were tenure or age, or then balance, and in the continuous categorical variables were a count, where a geography, gender, and a has card number. Okay, so this was our basic data analysis or continuous and categorical. Hello all, welcome to our next section of the project, that is the feature engineering. In this section, what we will do is we will basically try to make some new features which will help us in more providing more accuracy of the model, and then we'll do some pre-processing techniques, right, in like the one hot encoding or feature scaling, in order to process our data and feed it into a model in a way it can understand better. So first what I'll do is we'll make us new column which is called salary balance ratio. Now what this is, what I did is, in the previous section we saw that nor the balance nor the estimated salary had much impact or did not have much relationship from the churn. We did not find out any much relationship or information that based on this balance or estimated salary we can find out that okay, this customer will churn or not. So what I did, I combined both of them. I took a ratio and then I plotted a box plot. Now after that, what I found out that there is some information we can interpret with it. Okay, the person which is having a higher salary ratio around 2 is more likely to get churned. Okay, this is not much of a valuable information, but this is some sort. Now moving on, the same thing I did first for tenure by age. But seeing from the graph, we found out that there is not much relationship. Most of the person are having the same tenure by age ratio, that is between 0.0 to 0.25. That's why there is not much variation. So this was some of the features which I thought which could be of help. The feature engineering is basically done by the people who are having much of a domain knowledge. Okay, so they can create more of the features and find out that okay, which will have more of the impact and which will have more of the relations. This is best done by that feature, or it is best advised by that person who is the domain expert. Now what I did, I'm printing my categorical variables. What are my categorical variables? For that I simply made a function, and which I named print unique column variables, in which for every column in my data frame, if the data type is object, I am printing my column. Okay, so there is where only two. There the geography, that is a France, Spain, Germany, and the gender, which is the male and female. Okay, so now moving on, what I'll do, I'll replace this gender column. So I cannot simply, what I can do is I can also create dummies. Either I can create dummies, or I can replace it, or what in simple words we say label encode. Okay, I can label encode it. So in order to demonstrate both, what I have done, first I have done label encoding. Okay, I can what I'll do, I have done label encoding. Label encoding, this is label encoding. I can do this via the importing my label encoder. This is a very small numbers, male and female, that's why I simply replace it male with 1 and female with 0. What label in female with 0, what label encoding does, it replaces the category or continuous or the variable, categorical variable with some number. Now the second is our one hot encoding. This is our one hot encoding method. This is our one hot encoding method. This is a one hot encoding method. Sorry. Okay, so in way what I do is I'll create my dummies for the geography column. Okay, geography column. So what this will do, you will see what this will do. What I did is I write a command pd.getDummies. Then I have, there were three different attributes, right? So I got three different columns. First is the geography France, second is geography Germany, and the third is geography Spain. So what did the getDummies do is it created three new columns, and in the row which has that geography France as true, it provided a 1 and rest all for 0. Like in the first row, the geography was France, that's why it is 1. In the second column, the geography was Spain, that's why it is 1 in geography Spain, rest is 0. And similarly for all the rows. So now this is our one, we have done our label encoding and one hot encoding. Now for our continuous variables, what we'll do is we'll scale these features. Okay. Well, as you can see, our neural networks are very much respectable or very much affected by the feature scale method. Okay, so in order, we cannot provide the direct data for long variation data. What we have here is we have a very long variation, like see, credit score is ranging from 600 to 850, balance is ranging from 0 to 12 1 lakh 25,000 of that sort. So what we have to do, we have to scale these in a particular proper manner. So what I have did, I have defined a list in which I did the variables which I want to scale, which is the tenure, the credit score, age, balance, number of products, and estimated salary. I imported min max scaler. You can also use standard scaler. Standard scaler will scale those values on the basis of, let's see our data set first. The standard scaler will scale those values in a short period. Okay, in a short way. In min max scaler, what I did is scale the values from a very small category. Okay, the standard scaler will scale your value from -1 to 1. Min max scaler uses a different formula. Both are the same, you can perform both of them and see which performs better. Here I've used min max scaler. You can also use standard scaler and see what are the different outputs on your result. This you can take as an assignment. So now what, this is our final data set. Okay, we have dropped the let me see if I have dropped the geography column or not. Okay, yes, we have dropped the geography column because we did the one hot encoding part. Okay, we did the get dummies part. Okay, so this is my these are all my data is perfect. Now I can feed this data into my model. I'll create my dependent and independent features. So now this is my independent features. This is my, let me write it, independent features, and this is my dependent feature. This is my dependent feature x, in which what I did is simply drop the exited, and this is my df1.x, only my dependent feature. So now what I did, I split it into my dependent independent feature, then I imported train test split, and then I splitted my train and test data. I use a size of 80 to 20 ratio, which is test data is my 20%, train data is my 80%. Now if I'll see my xtrain dot column length, this is my 14 columns, and because initially I had 15, the one is my exited column. So this was my whole feature engineering and data pre-processing part. In the next section, we'll see how we can implement the sequential model and how we can predict the results with the help of it. Hello all. Welcome to our next section of this project, that is the model building and prediction. using the machine learning techniques. As I mentioned earlier, we are using the artificial neural network. In that, we'll be using the sequential model. So as I told earlier, artificial neural networks, or basically neural networks, are the algorithms which uses basically the different hidden layers to make the predictions. Now, artificial neural networks mainly resembles the human brain, how a human brain functions. Similarly, it functions in the basis of that. So, artificial neural network is a kind of unsupervised learning in which the model learns itself from the data present. So now there is something about sequential model. A sequential model is appropriate for a plain stack of layers where each layer is exactly one input tensor and one output tensor. Now, a sequential model is not appropriate when either you have multiple inputs or multiple models, or you need to do layer sharing, or you want non-linear topology. Clearly, we don't have any of the conditions, so we are good to go to use a sequential model. So now what I'll do, I'll import TensorFlow as TF, then from TensorFlow I'll import Keras, then I'll define my model, then Keras I'll dot sequential, then I'll give 3 layers. Okay, you can give 2 layers, 3 layers, as many if you want. Now Keras dot layers, I did the input shape 30 to 49. In first layer I gave the input function ReLU. Then in the second I gave the second layer also my input function activation function ReLU. Then my second activation function is also ReLU, and my third layer I gave my activation function the sigma. Then in the final I compiled my model using the Adam optimizer, which is with the binary cross entropy loss function, and the metrics I use is accuracy. Now I fit my model. I've already fitted because it would have taken some time, around 2 to 3 minutes, to fit my model, because I have trained there 100 epochs, right? I hope you are familiar with epochs. Epochs is one proper forward propagation and back propagation. Total process of forward and back propagation is called one epoch. And then I have performed 100 epochs. So my model performed 100 epochs, and as you know, the loss function get degraded after every iteration. I got an accuracy of 86.25 in my last iteration. Okay. Now what I'll do, I'll evaluate. I'll evaluate with my X test and Y test model, and this is the model. The same thing it is showing here, the loss function and the accuracy. Now I'll predict. Okay, I'll predict my results. As you know, my model has predicted my results, but there is one problem, that my model has predicted these probabilities. Okay, so I need to convert them into 0 and 1 forms, my output form, in order to check the accuracy. So what I'll do, I'll define an array, then I'll say for element in yp is my predictions, for element is my this each element. Okay, for element in yp, if the element is greater than 0.5, okay, if the probability of it's greater than 0.5, then it will append 1, otherwise it will append 0. So what will do, the element, the result which is having the probability more than 0.5, which means it is a yes. Okay, it means that the customer will churn. So the same, and the vice versa, it will map those results, and it will give me a prediction, my y prediction. As you can see, my results are converted into 1 and zeros. The 1 is basically, it means that it is the person has churned, and 0 is the person has not churned, that is, it has retained, it is a faithful customer. Okay, now moving on, we have to check the accuracy. Okay, so I have defined imported confusion matrix and classification report. First I'll see my classification report. So as you can see, my precision score is 0.88 for the 0, and the 1 is 0.69. Recall is this, F1 score is this, and overall accuracy is 0.86. Then what I'll do, I'll import a confusion matrix. I'll plot a confusion matrix. Okay, so from C1 I've plotted a confusion matrix. This is the simple command, cm is equals to tf dot mass dot confusion matrix. Labels I have given from my y test, and predictions are my y print. Okay, this is the some visualization settings. I just figure size and anode basically maps the text on your confusion matrix. So as you can see, these are my true positives and true negatives. This is my false positive, false negatives. As you can see, a main aim for a confusion matrix, that if the confusion matrix is good, it means that we should have the least number of false negative and false positive. Yeah, so this was our confusion matrix, and finally we can see our accuracy score from sklearn.metrics accuracy score. So this is the same accuracy score which our model showed earlier from when we trained it. Okay, see 0.8, 6.25. Okay, this is the same accuracy it is showing me here. This is the best. Okay, 85.6 accuracy around of the at that. So this is the the average accuracy of the model. So this was a small tutorial on how you can build your 10 ANN or sequential model. In the next section, we'll see how we can do all of these things and how we can try different models with the help of automated machine learning. That is how we can automate all of these things. We can do more of things in hyper, like we can hyper tune a model. We can try more different models. But I did this in order to, for the sake of comparison between auto machine learning and machine learning model. So in the next section, we'll be seeing different models, we'll be comparing them and observe and applying one of them, the best model, by using the H2O AutoML. Hello all, welcome to a final section of our project, that is the model building and prediction using the automated machine learning. Now I have discussed earlier, automated machine learning is a process which helps the data scientists to automate all the machine learning building part and hyper tuning part. In this project I'll be demonstrating you what is H2O AutoML library. So now H2O AutoML library is a fully open source distributed inbuilt memory machine learning platform with linear scalability. H2O supports the most widely used statistical and machine learning algorithms present, like the different deep learning models and the scikit-learn models and the sklearn models of that, all of them, including gradient boosting, generalized linear models, deep learning and many more. So now the first thing we have to do is we have to install the automated machine learning. Now if you are doing your project in a Google Colab or a Jupyter environment, you can install it directly in your notebook by writing these commands. Just write exclamation mark pip install request, then tabulate, then colorama, then future, then H2. Then finally we'll install our H2. Okay. Now let's execute this. I have already installed, these libraries are already installed in my system. That's why it is saying requirement already satisfied. It will approximately take 1 or 2 minutes in depending on your internet speed and processing power to get installed. Okay, now let's install our H2O library. As you can see, it is downloading around 168.4 MB of the data of our H2O. Basically, it is downloading all the different libraries present in our H2O, all the different models. Okay, it will take some time, around a minute or two. All my different libraries are already present. That's why it is saying requirement already satisfied. So now, the one thing about H2O is the H2O can do all the data pre-processing techniques also, right? H2O will do all these things for us. In H2O, we can perform one-hot encoding, we can handle NaN variables, we can handle categorical variables. These all things H2O can done this. Only the feature engineering. It is often said that feature engineering also handled by H2O, but I would not recommend that, because feature engineering can be done best by the domain, the person who is having the domain knowledge, because he or she knows what all are the features to add in order to amplify our model, in order to obtain the best accuracy. Okay, so now our H2O has installed. So now what we'll import our H2O. Okay, import H2O. Then from H2O.automl we'll import our automl. So now we'll write a command H2O.init. So now what this init is, init makes sure that the no prior H2O instance is running, because okay, so it makes sure that no prior H2O instance is running. So now our H2O is imported. You can see the different servers and different information. It is, as you can see, it is the server is running on this. You can use this server and go to another link and you can create your model there, but we'll be doing in our this notebook environment only. We'll be using the Python. Okay, so the similarly, like we read the data from pd.csv from pandas, we'll similarly write a command h2o.import file, and we'll give the path. The path, I have shown you how we give the path from in the in my first module in importing data sets. So now we'll see our data. As you can see, this is our data. This is a similar data which we have shown in the form of data frames. Okay, this is the our H2O data form. So now what we'll do, we'll split our data into train data and test data. We'll take the ratio 0.8. Okay, df dot split frame and 0.8, which means the 80% is train data and 20% is test data. Okay, so now data is splitted. We'll see our train data. Okay, see, here's my train data and the rest will be my test data. Now, so now what we'll do, we'll create a dependent and independent columns. Okay, so now this y is my dependent variable. Okay, and these x is my indi independent variable variable. Okay, y is my exited, this is my dependent variable. I am writing this, I am defining here. Okay, I am defining the name. Okay, y is exited and x is df all the columns. Okay, in that I am removing the customer id, row name and surname because these are of no use. Okay, that's similarly what I did in the machine learning part. Okay, so now I have named, I have took all the names in my and stored in my y and x. Now what I'll do, I'll define my model. I'll write AML is equals to H2O auto ML. What I did, I defined a maximum runtime. These are the different attributes. Okay, these are different attributes that you can give into the H2O auto ML. You can have a look at their documentation. All of the different information is provided. Then you can see which is the best for you. Okay, I have defined a maximum runtime second, which means it will run for 300 seconds. You can select 120, 180, and then I have set that maximum models 10. Okay, check maximum 10 models, not more than that. Then I've used the maximum number of seed 10, then all the other parameters. Now what I've done, I've used there n fold 0. You can use n folds number, n folds of 2 or 3. What we'll do, will it is n fold is 0 done is done when we have a validation data. Now we don't have any validation data. What we'll do, we'll select n fold, number of folds is 2. So now we'll define our model. Then what we'll do, we'll fit a model. Okay, it should take a minute or two. Okay, it's saying x is not defined. Okay, I have not executed it, sorry. So now I'll train it. So now it is saying auto ML in progress. Okay, now it will fit all the models. It will take around a minute or two. As I've selected the time 300 seconds. Okay, it will not take more than that. It will take. It can take less than 300 seconds, but it will never exceed 300 seconds. What it means that whatever you get in that 300 seconds, compile it and give it to me. Okay, it will be checking 10 models with a number of folds to it. It will be checking two times. Okay, it will holding the data two times. Okay. So now what I did is X is my basically the columns which I stored here, removing the customer ID, row number and surname, and Y is basically my exited columns. Okay, and the training frame which is the data which I have to take is the DF train data. Okay, as you can see, these are the different models which are getting trained. Okay, as now you see, first the model was trained was the first model was XG boost, and then the gradient boosting model, the different gradient boosting models, different XG boost models. Okay, these were the models trained. Now, as you can see, our model is fitted. This is the time. Okay, this is the timeline which is showed that what all things were happened at that time. So now we'll see the leaderboard. Okay, we'll see the leaderboard that it will provide us the list of models which perform the best. As you can see, stacked ensemble all models. Okay, what this did is the ensemble model, it stacked all the models which were all used. Okay, it stacked the model, and this method provided me with the best accuracy and the least of the deviance and errors. Sorry. So now what I'll do, then I'll take all the model IDs, I'll take all these model IDs and store it in a list. As you can see, this is my list, this is my all models. So now what I'll do, I'll check that what is my best performer. Okay, I'll check on my DF test that which model is my best performer. As you can see, the stacked ensemble model is my best performance. I have the mean square error, root mean square error, MAE, R square error, and all of the different things. So now what I'll do, I'll get the best performing model. What I'll do, H2O.get model, I can either directly write the name of the model, or what I'll do, I'll write a command H2O.get model mid. For mid, I'm defining a parameter mid in models.id. This is the model ID, the list in which I'll search for. I have the best model is stacked ensemble. Okay, so I'll search for stacked ensemble. I'll copy it, I'll paste it here. Stacked ensemble in mid. Okay. So now as you can see, this is my model. It gave me the detail of my model. What are the things were there were two models. Okay, the stack two is stacked ensemble models. The first one was the all model, and second was the another stacked ensemble model. So now we'll be finding out which is the best parameter. We'll be finding out which is the best parameter. Earlier I did some changes in that it gave me the GBM model, but now what I did, I used the number of 4 to 2, so now it is giving me stacked ensemble model. So what I'll do, we'll change the GBM to stacked ensemble. Okay, we'll do the same and we'll find out what were the parameters used in our model. So these were the parameters which were used in that model, all the different parameters. Okay, so now what we'll do, we'll write up variance important plot. Okay, sorry, this model does not have, okay, this model have not any importance plot, because earlier I was using a GBM model. Okay, now it has used stacked ensemble model, that's why it is showing that error. So now what I'll do, that I'll use the similarly I use AML.leader. What I did all the details of my leader model, which is the best performing model. Now I finally predict with that model. Why predict is equals to AML.leader.predict. I'm using my test data. Now I'm seeing my predictions. Okay, so now see, here is my predictions. Okay, these are my predictions. These are in the form of probabilities. You can convert them into a 0 or 1 form. You can either do that, or you can directly deploy this model in order to check the accuracy. So this was a brief introduction about the H2O AutoML. You can visit their website, see their documentation. There are multiple number of various amounts of things that you can do with the help of H2O AutoML. This is a very vast library. This was just a brief introduction to get you the idea of how what H2O is and how it works and what are the basic commands. So all the notebooks and videos will be provided to you, and this notebook is also provided to you with along with that training and test data. You can have a look, you can practice on your own, you can create different models with the help of it. Thank you.